Hello, welcome back. Today we're going to be talking about domain and range from a graph. The objective is that by the end of this video, you should be able to find the domain and range of a graph. To get us started, we've got several definitions, of which our input. The input are all of our x values or independent variable values. Our outputs are all of the y values or dependent variable values. The domain are all of the inputs, and the range are all of the outputs. I have a short story to remember all of those words or definitions and how they fit together. I had a friend that thought he broke his leg and he had to go to the doctor. When he got there, they asked to see his ID. In order to know if his leg was broken, they had to take an x-ray. Well, it turns out that his leg really wasn't broken, so he was quickly in and out of the office. So what does this have to do with domain and range? Well, if we look at it, a friend had to go to the doctor. When he got there, he had to show them his ID. And to find out whether or not his leg was broken, they took an x-ray. But his leg really wasn't broken, so he was in and out of the office in a flash. Now, what this allows us to do is to keep track of the letters. Domain and range, independent, dependent, x and y, input, output. So the domain are all of our independent variable values, which are usually all of our x values, which are our inputs. The range are all of our dependent values, or all of our y values, which are all of our outputs. We're going to be using inequality symbols in order to represent our domains and ranges, so please, if you feel like you can do this, you can actually do this in your head, or you can write it out in words if you need to. See if you can write the following inequalities in words two different ways. Now that's kind of the trick. Usually we're used to reading inequalities from left to right, but you can also read them from right to left. If you want to, go ahead and press pause, think about the answers to all those, and press play when you're ready to see the answers. As a quick review, the smaller pointy end of your symbol, that's always the smaller side. The larger end, that big open end right here, is always the larger side of the inequality. Now what this means for this particular problem is that 3 is less than 4. Well, that's obvious. But it also means, we can read that, that's reading it from left to right. If we read it from right to left, it reads as 4 is greater than 3. Let's take a look right here. We can read it from left to right as 4 is greater than x. You can also read it from right to left as x is less than 4, because x is on the pointy end, which means x is the smaller thing, 4 is the bigger one, so x is less than 4. Brings us to our next set of symbols, this little or equal to symbol. That means x can actually be equal to 5. So we read that one, we can read it two ways. And this one takes a little longer to write out. From left to right, x is less than or equal to 5. Or you can read it as, from right to left, 5, and that is a 5, is greater than or equal to x. So let's talk about some x values real quick. What's some x values we could actually put in that are less than or equal to 5? And that lets us know, well, x could be 4, because 4 is less than or equal to 5. X could be 5, because 5 is equal to 5. X could be 2, -2, -6, -100, -1000. Any number that's less than or equal to 5, x can be. Let's take a look at the next one. X is bigger than or equal to 7, or 7 is less than or equal to x. This leads us to our compound inequalities. I know that's a bit of a mouthful, but it's important we take a look at these because these will be showing up today for sure. And those are the ones where our x value or our y values will be between two numbers. This is read as one large statement. 3 is less than x, which is less than or equal to 7. Or more importantly, x is, let me keep the colors consistent. What we're going to do is we're going to read the left-hand part of it first, from left to right. So, sorry, from right to left, and from left to right. There's actually two parts to this inequality, the one in green and the one in black. So this says x is bigger than 3. It also says, let's add the word and, since x is the middle, and x is also less than or equal to 7. Basically, this means that x is between 3 and 7, but x can only equal 7. In other words, x can be equal to 7, but it can't be equal to 3 because 3 did not have the symbol underneath the less than, or rather inequality symbol right there. Go ahead and try to write that last one in your head or on paper in two different ways. Pressing pause, you can press play when you're ready to see the answer. I'm just going to say this one out loud. Y is bigger than or equal to -2, and y is less than 10. Basically, this means that y is between -2 and 10, but y can only be equal to -2. It can't be equal to 10. Here's one for you to try to write out on your own, plus you can also answer the questions about g, what g can be equal to. Go ahead and try this on your own, pressing pause, and press play when you're ready to see the answer. Alright, for the answer, we note that g is greater than 3, and g is less than or equal to 15. This means g is between 3 and 15, but g can only be equal to 15. Can g be equal to 3? No, because 3 does not have the little underline underneath that symbol. Can g be equal to 15? Yes, because you'll notice that before the 15, you have the little underline. Can g be equal to -5? Well, -5 is not between 3 and 15, so that is a big no. Can g be equal to 7? Since 7 is between 3 and 15, the answer to that question is yes. To introduce domain and range, let's look at a situation. Suppose Heidi went for a hike down and then back up a mountain. We're going to put the mountain in her home on a graph. The negative y values will be how far she hikes down the mountain. The positive y values will be how far she hikes up the mountain. The x values will be how far away from home she walks. So here's our mountain. In green, there's Heidi's home. And we're going to take Heidi and we're going to start her off at home. She's got a couple goats with her. They're going to graze the mountainside, and she's going to take them off to find some other pastures to graze. So she hikes down the mountain. She gets to a valley and climbs up the other side to get to the good grazing grounds, gets up to the top, and they stay there and they eat. Now you may be wondering, what in the world does this have to do with domain and range? Well, we're going to be using Heidi and her situation in order to talk about what domain and range really are. Now domain, remember, is all of our x values. So in this situation, the domain, which I will do in black, will be the distances that Heidi walked. Now Heidi started here, at home. She started at 0 feet from home. And she walked and walked and walked and walked and walked, and she stopped at the grazing grounds 200 feet away from home. So again, let's show that again. She started here and then walked all the way to 200 feet away from home. So the domain values would be from 0 to 200 feet. So she walked from 0 to 200 feet away from home. Now the way we're going to actually do that in this class for graphs is we're going to abbreviate from 0 to 200 feet using inequalities. Now if you remember, inequalities are your greater than and less than symbols. So let's talk about her walk. All of her x values of her walk were from 0 to 200. So they were from 0 to 200, and she started off at 0 feet. So her distances were bigger than or equal to 0 feet. Notice the bigger side of that inequality symbol means that x is bigger than 0, and the pointy little side, the side that's a little pointy, means it's smaller, so x is bigger than the smaller 0. So all of her distances were bigger than or equal to 0, that's where she started, and they were less than or equal to 200. She actually stopped at 200 feet, so less than or equal to 200. So what we've done is we've written the domain of her walk. She walked from 0 feet to 200 feet. The way we write that in math, in symbols, would be their x values are bigger than or equal to 0, and they're less than or equal to 200. Why? Because her walk was between 0 and 200 feet. Now let's suppose we take the same situation and let's look at the range of the situation. If you remember the range, let's do that in another color. The range would be all of the y values. So that would be how far down and how far up the mountain she walked. Now she started off at home, and remember our y values, negative means how far below the house or how far down she hiked from the house. Now if you look at it, she hiked 90 feet. She hiked all the way down to 90 feet below. And then she hiked back up the mountain, so that was the lowest value that she hiked down to. She hiked back up the mountain, and she hiked and she hiked and she hiked and she hiked until she got all the way up to 75 feet above the house. So the range would be from the lowest place on the graph, negative 90, to 75 feet. Now range, again, our y values, she walked all the way down to negative 90 and all the way up to 75. So it's from negative 90 to 75 feet. The way we list that is our y values are between negative 90 and 75. So our y values are bigger than or equal to negative 90 and less than or equal to 75. And there you go, we've written the domain and range for this particular situation. Let's take a look at another situation, and in this case we're not actually going to be putting it in a real life situation, it's just going to be a plain graph. And we're going to talk about domain and range in this particular situation. Now we can still think about Heidi and her walk, but it gets a little bit different because we didn't have negative distances in the walk. However, a lot of the ideas will still be the same. We're going to add one new thing to this example right here, which specifically is this open circle right here. This open circle means that you walk towards that spot but can never actually get there. You can get as close as you want, but the open circle means you never actually touch this point. That's why the circle isn't filled in. And if you can't touch a point, that means you're going to either use a less than or a greater than symbol. You're not going to use the or equal to symbols because you can't actually equal that point. However, a closed circle means that we can touch the point or do touch the point. Can reach or touch or get to. So we're going to use the less than or equal to or the greater than or equal to symbols. Again, let's keep that in mind as we work this out. Domain, let's go and do domain in black again. So if we're talking about a walk, we're going to walk along this graph, and we're always going to start at the furthest left that we can start. So we start, and we're going to start our walk right here at -4. That's where the walk starts. So our walk starts at -4, and we keep on walking. We walk from left to right, always from left to right. Keep on walking until we get all the way to 2. So all of our x values are going to be between -4 and 2. The main difference here is that you don't actually start or be able to touch the -4, so we do not write an underline underneath that. However, we do walk all the way over to 2, so we do get an underline underneath the 2. Now when we talk about the range, we talk about how far down. So if you're walking, you're doing your little hike here, it's how far down you go. And you notice we go all the way down to -4. So our range starts at -4, but here's the weird part. And we'll talk about the weird part here in a second. We go down to -4, and then we walk up, all the way until we get up to +4. So the walk was between -4 and +4 as far as the heights go. The y values are range. So the y's went all the way down to -4 and all the way up to +4. Here's the weird part. You actually reach -4. That's actually a height that the graph itself touches. If this was your walk, you walked all the way down to -4. It's not an open circle. So you use an underline. All the way up here, you actually touch the +4, so you use an underline right there. So notice in this case, the domain and range do not match up. For the range, we have underlines underneath both of them. For the domain, an underline only underneath the 2. And that again was because the open circle was our starting x value at -4, and we couldn't actually touch that value because it was an open circle. So look at our second to last concept. This one's a little different from the previous one, mainly because it's got this arrow which really doesn't look much like an arrow. Let's make that look like an arrow. Got this arrow right here, which means your graph, anytime you have an arrow, that means the graph goes on forever. So our graph is going forever to the left and forever up. Let's go ahead and write that because that's real important. We need to recognize that it's going forever left because the arrow is pointing to the left slightly, and forever up. So our graph again is going forever to the left and forever up, and you'll notice you got this little open circle here again. That means it does not equal this particular point. So let's talk about domain in this situation. Now domain, we have to do our starting point from left to right. Keep that in your mind as you do domain. Domain, always from left to right. So let's go ahead and find out where we start off to the left. Well, we're looking at our graph here, and there's actually no starting point to the left. So we don't even write a starting point down. It doesn't start anywhere to the left. So our x values go from, well, way off to infinity somewhere, negative infinity, all the way over to 1. So if you're walking, or maybe this is a huge slide, yeah, let's make our person slide. Person slides down, all the way down and all the way over until they get to 1. So our x values actually are less than 1, but we don't have a lower bound, so we don't actually write anything. Our x values are less than 1. They just go on forever to the left. Let's talk about our y values. Now remember, our y values are our lowest to highest. So domain, again, we got x is less than 1. And for our range, now you want to keep in your mind that range is always from bottom to top, lowest to highest. So our range, lowest to highest, your minimum to your maximum, our range, our lowest value on the graph, if you follow it all the way down, it stops at 0 as the lowest point. It actually stops, it just reaches 0. That's the lowest y value. So our lowest y value is 0. Our largest y value, if we keep on going, the slide goes down and comes back up, stops at 1 but doesn't actually touch 1. So our y values are bigger than or equal to 0 since it actually touches 0, and less than 1 because it doesn't actually get all the way up to 1. That little open circle means we don't actually touch it. It cannot be equal to 1. So that's how we write our range in this situation. And now we're to our last type of problem, and we're going to do it the exact same way we did the other ones. Our domain, remember, again, is from left to right. So we're going to follow the graph along to the left to find the starting point. And you'll notice in this case, it doesn't start anywhere to the left. It goes on forever to the left. Since it's going slightly to the left right here, it's going forever to the left. Well, let's see if we can find an ending point to the right-hand side. So we follow along, we walk along the graph, walk along the graph, walk along the graph, walk along the graph, and keep on hiking till we get to the other side, always from left to right, and we see that there's no ending point either. So we're going forever this way too. That means that you're hitting every single number along the graph. So what you do is, in this case, is if it goes on forever both directions, to the left and to the right, or to the bottom to top, in this case just the left and right, we say that the domain is all real numbers. Now the reason again we say all real numbers is because it's every single number to the left and every single number to the right. So we say all real numbers. Another way you could write that is negative infinity to infinity. All your x values are between negative infinity and infinity. We can't equal infinity, so we use just the greater than and less than symbols. I actually accept either one of those answers, although I much prefer all real numbers. By the way, this up or sideways 8 is the infinity symbol. It means forever. The range. Notice our graph goes down forever, so there's actually no starting point. Remember, again, your range is from bottom to top, so the range went down forever, and it goes all the way up to 4. So all of our y values, since we have no starting, we don't write anything to the left, and our ending point is 4. So all of our y values, it actually goes up and touches 4. All our y values are less than or equal to 4. And there you go, we've written our domain and our range. Here are 3 graphs for you to try on your own. Please press pause, work them out, and press play when you're ready to see the answer. Now for the first example, both the domain and range had a starting value. The domain starting value was -3. That was the least or the smallest or the leftmost x value. Sorry, -3. But it went on forever to the right, so we actually didn't write a value there. The range started at 0. That was the lowest y value. And it went up forever, so we didn't write that value. Now, anytime you have this, you'll usually see it not written as -3 is less than or equal to x. You usually see it written the other way around. X is bigger than or equal to -3. So that's our domain. Our range, y is bigger than or equal to 0, is how you'll typically see that written. They'll usually write that the opposite way when you have a lower number but not a higher number. For our next graph, I got the domain had no lower value, no leftmost value because it went to the left forever. Didn't have a rightmost value because it went to the right forever, so it was all real numbers. The range, by the way, that symbol right there means numbers. A range went down forever and up forever, so it was also all real numbers. And for our third and last graph, we're going to find our domain and range. So for our domain, this one can be a little bit tricky. Notice it starts at -3, that's our leftmost value. And our rightmost value is 0. Our x values are bigger than -3, since you can't have that filled in right there. It doesn't actually touch -3. You can't use a filled in circle. And our rightmost value is 0 with a closed circle because it actually touches 0 on the x-axis. By the way, that point is 0, 4. The x value is 0, the y value is 4. Since we're talking about domain, our x values, it stops at 0. Now for the range, our y values start at -2, because again, that point is -3, -2, x, y. So our y values right here are -2, the lowest value on the graph, -2. And our tallest value, our upmost value, going to the top, the highest, is 4. So our y values are greater than -2, can't touch it because it's an open circle, and less than or equal to 4 since you can actually touch 4.